Good morning. Today is Wednesday, November 18th. If you missed today's lesson in our Zoom meeting, you're going to need to watch this video to get caught up on checkpoint 3 today. So you're going to need to go to Summit and go to your year view, and you're going to open Forces in Motion project. And we are on checkpoint 3, which is number 2, Newton's second law. You're going to open that, and we are going to start by doing Newton's second law of motion, definition, examples from class, a picture, examples from everyday life. So as I'm going through the definition, you need to be filling that note taker in. So the definition of Newton's second law of motion is the greater the mass of an object, the greater the amount of force needed to accelerate that object. And we really focus on this equation down here. Force equals mass times acceleration. Those are the three terms that we hear most when talking about Newton's second law of motion. So you're going to want to put this definition in this part of your note taker. Okay. So the acceleration of an object is going to depend on the mass of it and how much force is applied. So in these examples, we're going to be labeling the force, the mass, and the acceleration. So in this trailer being pulled by a car example, the car is going to be the force, the mass is the trailer, and the acceleration is the car and the trailer moving forward. Now, since this is a larger object, it is going to take more force for this to get accelerating and get moving. Over here, we have the fishing example. We have the fishing pole is the force and the reel reeling it in. The mass is the fish, and it is accelerating upwards because of the force from the fishing pole. In the dandelion and the wind example, the mass is going to be the tiny little dandelion. The force is the wind, and then the wind is going to accelerate the little white fluffies to come off of the dandelion. In this shopping example, we have the mass is going to be all the shopping carts and the shopping bags this lady is holding. The force is going to be the muscles on the shopper, which will then accelerate her forward and to keep on shopping. So there you have some different examples from class, and you can use different examples for every day. The dandelion example would be a good every day, and then any of the other examples would be good for just class. And then you'll also just want to look up a picture that helps you remember Newton's second law of motion, and then insert that picture. Now we're moving down to mass and acceleration. So we're going to do a definition and an example. So mass is the amount of matter in an object. Mass is a property that resists changes in acceleration. Okay, so here is your definition for mass. And then we're going to go ahead and skip down to acceleration. So acceleration is a change in how fast an object is moving. A change in how fast an object is moving. So we have some different examples going on about how mass impacts acceleration. So here we have this bulldozer, we have a truck with wood on the back of it, and we have a sports car. So this is going to have the most mass, and the sports car is going to have the least mass. So it's going to take a lot less force for this car to accelerate. Okay. And then this truck and this bulldozer are really going to get off to a slow start, and they're not going to be able to get going as fast as the sports car. All of these can go fast, but they all cannot change their speed at the same due to the amount of mass they have. So it's going to take a lot longer for the bulldozer and the truck to slow down. It's going to be faster for the sports car to slow down. So the mass is going to depend on, or the acceleration depends on the mass of the objects and all that good stuff. So This says doodle, describe and doodle how each scenario might change a bicyclist acceleration. So what if the rider pedals twice as hard? So if the person is on a bicycle and pedals twice as hard, adding more force to the same mass is going to increase their acceleration. Okay. This next example says, what if the rider adds a heavy backpack? So same person riding adds a heavy backpack. So more mass with the same force is going to cause a decrease in the acceleration. If I keep pedaling the same speed that I was going before the backpack, I'm going to end up slowing down once I put the backpack on my back. Okay. So those are some different things that you can put for examples from class. And then I gave you the definition. All right. All right, so now we're going to focus on this Newton's second law CER. So the question is, describe how Newton's second law of motion is seen in this video. So you're going to click into this video link and it's going to take you to a video that you're going to watch. All right, so we have to come up with a claim. This is the direct answer to our question. So describe how Newton's second law of motion is seen in this video. So Newton's second law of motion is seen in this video because their same car went down the same ramp with different amounts of mass, causing a different outcome in how quickly the car came to a stop. So Newton's second law of motion is seen in this video because the same car went down the same ramp with different amounts of mass, causing a different outcome in how quickly the car came to a stop. So they were the same car going down the ramp. The first situation, there was no extra mass on the car. It was just the car. The second time, the car had some washers taped to it, which added more mass. Now, the first car came to a stop pretty quickly. It accelerated pretty quickly, and it came to a stop pretty quickly with no washers. The second time with the washers, it took a little bit longer to get going. It still got going pretty fast, but then it did take a little bit more time for that car to come to a stop because it weighed more. So our evidence is in the video, the car with no washers took a shorter amount of time to come to a stop, and the car with washers took a longer amount of time to stop. All right, that's our evidence. We saw that in the video. In this video, our reasoning is going to be supporting why our evidence, or talking about why our evidence supports our claim. So I know Newton's second law of motion is seen in the video because Newton's second law says that, we can even go back to what it says. Newton's second law says that the greater the mass of an object, the more force it takes to accelerate the object. In this case, we are looking at how long it takes for the cars to slow down. Okay, So that is what you should have for this CER. Hopefully you watched this video and you got all the definitions and the examples from class, picture every examples from every day, and then your definition examples from class for mass acceleration. Please request feedback when you're finished. And if you have any questions, please make sure to talk to your science teacher so that we can help you. Have a wonderful Wednesday.